For the regolith challenge, I knew one of the most important parts about entering would be able to build a full test sandbox that I could have completely to scale with all the dimensions and characteristics that the real sandbox would have out in California. It would be sort of worthless to be working on a project for many months and a lot of time and money into it and not be able to know if it really will work. So in that case, I knew I would need space to build a big sandbox. And in the ideal world, that sandbox would be right next to where I could build the robot, work on it, modify it, next to maybe a machine shop. And so I'm actually sitting in this lab here where the sandbox was built. And it's right next to the machine shop and right next to where I keep all of my tools and materials to work on the robot. So in this case, for the NASA challenge, the simulant is a very unusual material. It's very expensive. It's only made by one company. And it costs basically $400 for a 5-gallon bucket of this material. I built a setup that enabled the robot to drive forward just 1 foot while digging the simulant, just to make sure there were no problems. And it was enough, again, just to test 1 foot of digging. We made sure it worked, and then we put it back in the buckets and never used it again. And in that case, we built a big sandbox that had cheap sand. An interesting story was, we just got the cheap sand from Home Depot, and it had these little tiny rocks in it. They were only about an 1/8 inch big, but the rocks were big enough to get caught in the tank treads of the drivetrain. And again, that would not be an issue in the real competition, where we knew the material was very fine, almost like a powder. But in our test sandbox, it was a major issue, because the robot had the power to destroy itself. So what we did was, we had to hand sift 7,000 pounds of sand. We pulled out about 1,000 pounds of rock, was one of the funny parts. That was one of those mistakes where if we had done a little more investigation and found that the higher quality sand may have been a little more expensive initially, would have saved us about 2 days of work in the end, would have been very valuable. The nice thing about the sand we did use was it was so bad that it had lots of fine dust and powder in it. So as we would dig it, it behaved very much like the regolith and create a major dust cloud. And then in that case, we found out we would need these high-powered LED lights to be able to see our robot remotely with the cameras. So without that sort of bad sand, we would never really have seen how bad that effect would have been.